In this video, I'm going to start by looking at the recursive formula for a geometric sequence. And here we're given a geometric sequence. But first of all, let's look at the definition. This is a formula that allows any term to be computed from the previous term. And the first term must be given. So here, write the explicit and recursive rule. And here, so to write the explicit rule, I need to know the first term, and I also need to know the common ratio. So the first term here is equals to 4, and the common ratio is equals to 1/2, because that's what I'm multiplying by every time. Now, to write the explicit formula, I know the general rule is the first term you multiply by Rn minus 1. So this is going to be given by the formula, the explicit formula is going to be given by 4, and then this is going to be 1/2 n minus 1. So this is the explicit formula. Now when writing the recursive formula, I just need to state the first term. The first term is 4, and then to get the next term or any term, I just need to take the previous term, which is denoted by that, and then I multiply it by 1/2. And remember, this can also be written as 1/2 times the previous term. 1/2 the previous term. So those are my two formulas right there, the recursive and the explicit. So here we are going to look at how to find the sum of a finite geometric series. A finite geometric series is the one which has a definite number of terms. So the formula we are going to use is the sum of n terms is going to be given by A, which is the first term, and then we are going to multiply that by 1 minus r raised to n divided by 1 minus r. So that's a formula to use. So let's do some examples here. So the first one, we need the first 10 terms. So I'm doing S10 is given by, the first term is 3, and then I'm going to multiply that by 1 minus, what is the ratio? We are multiplying by 2 every time. So this is 2. N is 10 because we are looking for the first 10 terms. And then 1 minus r, which is 2. Then all I need to do is to simplify that. So I just put that in the calculator. And when I do that, the answer is 3069. So the sum of the first 10 terms. Now let's go to the next one. We are doing the same thing. So I already know the first term. So I need the 10 terms. So it's going to be the first term, which is 1. And then I'm going to multiply 1 minus, what is the ratio? The ratio, every time I'm multiplying by half, and that's going to be raised to power 10, and I'm going to divide by 1 minus 1/2, and I put that in the calculator, and I get about 2. That will be the answer. This one here is given in sigma notation, but we are doing the same thing. But for this one, I need to find the ratio, and I need to find the first term. So to get the first term, I need to plug in 1 into the equation, into the formula, which is given there. So this is 2, n raised 1, that's 10, and the common ratio is the one in parentheses. And in this case it's 5, because we are multiplying by 5 raised to whatever power. So that's going to be the ratio. So now to get the sum of, it's continuation of the previous one, 10 times, it's going to be 10, and then this is going to be 1 minus r is 5 raised to 10. So 5 we raise it to 10, and then we can divide by 1 minus 5. Then I put that in the calculator, and it's going to be a big number. And that's the answer. That's what the answer is going to be. Okay, we do the next one here. Again, we need to find the first term. And this one is actually asking for the 30 terms. Find the sum of 30 terms, not 10. So 1 to 30. So the first term, I plug in 1. So this is going to be 8 since 2 over 5. N minus 1, 1 minus 1 is 0. 2 over 5 raised to 1 to 0 is 1. So just get 8. And the ratio is 2 over 5, which is the same as 0.4. Now I just need to find the sum of 30 terms, which is going to be equal to 8. And then this is going to be 1 minus 0.4, and we are looking for 30 terms raised to n. N is 30, n is 30, and then I'm going to divide by 1 minus 0.4, and that's what I'm going to solve. When I put this in the calculator, I'm going to get about 13.3. When I simplify that, 13.33 repeating, so that's the answer. So here let's look at an application for problem for geometric sequence, and we use it to find the compound interest. If P amount is invested at an interest rate R per year, compounded annually, the future value S at the end of the year, nth year, is going to be given by this formula right there. So here we have an example. Stocks of a company are initially issued at a price of 10, and then the value of the stock grows by 25% every year, and then we are told to calculate the value of the stock after 10 years. So I start by writing the formula. So the formula for finding S, the value of the stock, is going to be P1 plus R raised to N. And now all I need to do is to identify these variables. So P is 10, the rate is 25%, which is the same as 0.25, and I'm looking for 10 years, so N is 10. So the answer is going to be P is equals to 10, and then 1 plus 0.25, then we are going to raise this to power 10, and this is going to be 10, 1.25, we raise that to power 10, and that's going to give us 93.13. That's how much the stock is going to be worth in 10 years.